In this video, we want to learn about adding and subtracting rational expressions. To add or subtract rational expressions, first we have to find the common denominator. Look at this first example, 5 over x minus 1 plus x over x plus 2. We have to make the denominators the same. As you can see, the denominators right now are not the same. To make the denominators the same, we multiply the numerator and the denominator of this fraction by this denominator. So we multiply numerator and denominator of this by x plus 2. Then we have 5 times x plus 2 over x minus 1 times x plus 2. And for the other fraction, because we want to make the denominator the same, we multiply the numerator and denominator of this fraction by the other denominator. So we multiply numerator by x minus 1, and we multiply the denominator of this fraction by x minus 1. The reason that we have to multiply numerator and denominator by the same expression is that we want to multiply this fraction by 1. Attention, when you multiply an expression, the numerator and denominator of an expression by same expression like x plus 2 over x plus 2, the value of this fraction is 1, and multiplying anything by 1 doesn't change the value, the original value of that expression. That's the reason that we have to multiply numerator and denominator by same expression. And for the other fraction, we multiply numerator and denominator by x minus 1, and multiplying by this doesn't change the value of the original fraction. Now if you pay attention, the denominators are exactly the same. Please pay attention. This denominator is this denominator. If you are thinking that the order of the brackets is different, it doesn't matter, because in multiplication the order of the brackets doesn't matter. It's like 2 times 3 or 3 times 2. These are 6. So the order of the brackets is not important. Now we put one of the denominators and we add numerators. In the first numerator, if you pay attention, we have 5x plus 10. We multiply 5 in the bracket. And in the other numerator, we have x to the 2 minus x. If we simplify numerator, in numerator we have x to the 2, 5x minus x. 5x minus x is 4x. And we have 10 in numerator. And in denominator we have x minus 1, x plus 2. And you don't need really to multiply these brackets by each other. It's better to leave it in the factored form. And this is the final answer of this question. Now look at this example. 2 plus 1 over x plus 3. First of all, note that we can consider 2 as 2 over 1 plus 1 over x plus 3. Similar to the previous question, we have to make the denominators the same. We have to find the least common denominator. And for that, we have to multiply the numerator and denominator of this fraction by x plus 3, because we want to have same denominator for both of the fractions. So we multiply the numerator and denominator by x plus 3. And in denominator, we have 1 times x plus 3. But because it's 1 times x plus 3, really you don't need to write this 1 here. For the other fraction, we don't need to do anything, because already the denominator has x plus 3, and we don't need to multiply the numerator and denominator of this by anything, because you have x plus 3 here, and the other denominator is just 1. So multiplying by 1 doesn't change anything. So you don't need to do anything with the other fraction. So here, to make the denominator the same, the only thing that we have to do is to multiply the numerator and denominator by this, by x plus 3. Now, if you pay attention, the denominators are the same in both of the fractions. So the final answer is, write one of these denominators, and you don't need to put any bracket because we have only one factor in denominator. But for numerator, multiply the 2 in the bracket. Then you have 2x plus 6 plus 1, which can be written as 2x plus 7 all over x plus 3. This is the final answer for this question. Now look at this example. X over x to the 2 plus x minus 2 minus 2 over x to the 2 minus 5x plus 4. This is a little harder example, of course. As you can see, we have this denominator, which is different than this denominator. And maybe you are thinking, okay, we have to multiply the numerator and denominator of this fraction by this. That method works, but that is not the best way for doing these type of questions. Remember always, we want to find the least common denominator. And for that, when you have quadratic expressions in the denominator like this, first factor these quadratic expressions before doing anything else. First, basically, factor the denominators, if it is of course possible. So here we first factor the denominators. We have x over this trinomial can be factored as x plus 2 times x minus 1. Let me remind you, when we want to factor a trinomial, we put two brackets, x in each bracket. Then we look for two numbers that their product is negative 2 and their sum is 1 in this case. Two numbers that their product is negative 2 and their sum is 1. Those numbers are 2 and negative 1, because 2 times negative 1 is negative 2. 2 minus 1 is 1. So we can factor this trinomial in this one. What about the other trinomial? Try to factor this one by yourself. You should be able to factor this in your head. We are looking for two numbers that their product is 4, their sum is negative 5. Those numbers are negative 1 and negative 4, because negative 1 times negative 4 is 4 and negative 1 plus negative 4 is negative 5. Now look at the denominators again. We want to have same denominator. By comparing this denominator with this denominator, we notice that x minus 1 is common between them. So we don't need to be worried about this. This is common. But x plus 2 is here, but we don't have that factor here. So what we have to do, we have to multiply the denominator and numerator of this by x plus 2. And for the first denominator, what we have to do, we have to multiply numerator and denominator of this by x minus 4, because we want to have this factor also for this denominator. So here we have to multiply this denominator and numerator by x minus 4, because we want to have this factor also in this denominator. So we multiply numerator and denominator by x minus 4. So we have x times x minus 4. And of course we multiply the denominator, x plus 2 times x minus 1 times by x minus 4. And for the other fraction, we put 2 times, what is the factor that we need to have here? X plus 2. Because we have x plus 2 here, we have to have that factor also in the denominator here. So we multiply the numerator by x plus 2. And because we multiply the numerator by x plus 2, we multiply the denominator also by x plus 2. Now, if you pay attention, the denominators are the same. This denominator has exactly the factors that is in this denominator. Now that the denominators are the same, simply we have to write one of the denominators, and only we have to simplify the numerator. I write this denominator here, and attention, this denominator is the same as this. So we write one of the denominators. Now we have to simplify the numerators. X times x minus 4 is x to the 2 minus 4x. 2 times x is 2x. But attention, we have a negative here, so negative 2x. 2 times 2 is 4, but it's a mistake to write plus 4. It's a negative. This negative is for all the fraction. So this negative should be applied to every term in numerator. 2 times 2 is 4, but we have negative 4. So finally, we have in numerator x to the 2 minus 6x minus 4x minus 2x is minus 6x minus 4 all over x plus 2 times x minus 1 times x minus 4. And this is the final answer of this question. And again, you don't need really to distribute these brackets. leave them in the factored form. And it can be good idea if you can factor this numerator also. Maybe then one of the factors in numerator cancels with denominator, but this quadratic expression, this trinomial, cannot be factored. If you try to find two numbers that their product is -4, their sum is -6, you cannot find any two numbers, so leave it in that form. Now look at this example. 1 over x plus 2 over x to the 2 plus 3 over x to the 3. The denominators are different. The denominator is x, the other one x to the 2, the other one x to the 3. We want to have same denominator, so we have to find the least common denominator. What we have to do here? Here we have x, but here we have x to the 3, and this is the factor with highest degree. X to the 3, attention, is x times x times x. So this denominator has 2 extra x, x times x. So we have to multiply this denominator also by these extra x. So we have to multiply the first denominator by x to the 2. So we multiply the denominator and numerator by x to the 3. So we have already x, but we multiply by x to the 2 because now this is exactly same as this. And of course you have to multiply the numerator by x to the 2. And attention, if you cancel this x to the 2 with this x to the 2, it's again 1 over x, the original fraction. For the next fraction, what we have to multiply? The numerator and denominator. You have to multiply it by x. Then we have 2x over x to the 2 times x, which is x to the 3. And for the last fraction, you don't need to multiply by anything because already it is exactly x to the 3, which is the least common denominator. Now that the denominators are the same, we put one of the denominators, x to the 3, and we add the terms in numerators. Attention, this is x to the 3, x to the 3, x to the 3, these are the same. We add the numerators. So in numerator we have x to the 2 plus 2x plus 3. Look at this example. 1 over x to the 2 minus 1 minus 2 over x plus 1 to the 2. This denominator can be factored, so it's a good idea to factor this denominator first, then think to finding the least common denominator. So before doing anything else, before finding the common denominator first, we try to factor the denominators if it is possible. So we write this in the form of 1 over x minus 1 times x plus 1 minus 2 over, this is already factored, x plus 1 to the 2. And attention, x plus 1 to the 2 is basically x plus 1 times x plus 1. So we have this factor here, but it is repeated. We have this factor twice in the denominator. Now, what is the common denominator? As you can see, in this denominator, we have this factor, but we don't have this factor in the other denominator. So we have to multiply this denominator and numerator by x minus 1. But what about the first fraction? If you pay attention, here we have x plus 1 to the power of 2, but here we have only x plus 1 to the power of 1. So to make this similar to this one, we multiply the numerator and denominator of this by another x plus 1. So for the first fraction, we multiply the numerator, which is 1, by x plus 1, and we multiply the denominator also by x plus 1. Then in denominator we have x minus 1 times x plus 1, and because we multiply by extra x plus 1, so it would be 1x plus 1 here. But attention, you don't need to write it this way. X plus 1 times x plus 1 can be written in the more compact form, in the form of x plus 1 to the 2. This is the better way to writing that. For the other fraction, we multiply it by x minus 1. And of course, we multiply the denominator also by x minus 1. Now look at the denominators. They are the same. X minus 1 times x plus 1 to the 2. In the first numerator, we have x plus 1. 1 times x plus 1 is x plus 1. Then multiply the 2 in the bracket, and don't forget you have a negative here. So we have negative 2x. This would be minus 2, but because we have a negative here, so plus 2. The final answer would be x minus 1 times x plus 1 to the 2, and in the numerator, x minus 2x is negative x. 1 plus 2 is 3. This is the final answer for this question. Negative x plus 3 all over x minus 1 times x plus 1 to the power of 2. Now look at this example. 3 over a to the 2 minus 4 over ab plus 5 over b to the 2. As you can see here, we have two variables a and b. The process is the same. First, we have to find the least common denominator. And of course, before that, we have to check if it's possible factor the denominators. But already we have simplified denominators. So we have to try to find the common denominator, or basically the least common denominator. To make the denominators the same, we notice that in this denominator we have b, but in the other denominator we have b to the 2. So we have to multiply the numerator and denominator of this fraction by b to the 2, because this is the factor of b, but this one has greater factor, and so we always consider the factor with highest power. So for the first fraction, we multiply the numerator and the denominator by b to the 2. So 3b to the 2 over a to b2. If you cancel b2 with b2, it's again the original fraction. For the next one, we have ab in the denominator, but we notice that here we have a to the 2, and here we have b to the 2. So for this denominator, we need to multiply the denominator and numerator by a and b, ab basically. Because attention, this is the least common denominator. Here we have ab, but the common denominator is a2b2. So we have to multiply this by ab. So we have minus 4ab over ab times ab. We multiply numerator and denominator by this. And attention, ab times ab is a to the 2, b to the 2. And so it's a good idea to write the denominator in the form of a to the 2, b to the 2. Finally, for the last fraction, we multiply the numerator and denominator by a to the 2, which would be b to a2. If we cancel this, this is the original fraction. And of course, it's better to write the denominator in the form of a to the 2, b to the 2. Because b to a2 or a to b2 are the same, but this is better because now we can see that all the denominators are exactly the same. So we write one of the denominators and simply we subtract and we add the terms in numerator. In numerator, if you pay attention, we have 3b to the 2 minus 4ab plus 5a to the 2. This is the final answer for this question. Now look at this example. 1 over x plus 1 minus 2 over x plus 1 to the 2 plus 3 over x to the 2 minus 1. This denominator is already completely factored. This is completely factored, but this one should be factored first before thinking to finding the least common denominator. So the first thing that we do here is that we factor the denominator of the last fraction. We have 1 over x plus 1 minus 2 over x plus 1 to the 2 plus 3 over x minus 1 times x plus 1. Now this denominator is factored. How we factor this and we write it this way? Let me remind you this important identity. A to the 2 minus b to the 2 is a minus b times a plus b. This is the identity that we used for factoring this. Now, look at the denominators. we want to find the least common denominator. By looking at these denominators, we notice that in the least common denominator, we should have x plus 1 to the 2. Here we have x plus 1, but here we have x plus 1 with a higher power, and in the least common denominator always we consider the factor with the highest power. So we have to have this in the common denominator, x plus 1 to the 2, and we have to have this other factor, x minus 1. So the common denominator would be x plus 1 to the 2 times x minus 1. Keep this in your head, x plus 1 to the 2 times x minus 1. Now we have to make each of these denominators like this. How we can make this denominator like this? We have to multiply this, of course, by x minus 1, and also we have to multiply this by 1 extra x plus 1, because we want to have x plus 1 to the 2. What about the other fraction? How we can convert this to this? We have to multiply numerator and denominator by x minus 1. And for the last one, to make the denominator the same as this, we have to multiply the numerator and denominator by x plus 1, because here we have only x plus 1 to the power of 1, but we need x plus 1 to the power of 2. So we multiply the last fraction by 1 extra x plus 1. So let us start doing this. So for the first fraction, we multiply the numerator and denominator by x plus 1 times x minus 1. And because we multiplied the numerator by this, we multiply the denominator, which is already this, by x plus 1, x minus 1. But attention, you can write this in the form of x plus 1 to the 2. So the better way to write the denominator is x plus 1 to the power of 2 times x minus 1. This is for the first fraction. For the next fraction, we multiply the numerator by x minus 1, and we multiply the denominator also by x minus 1. And finally, for the last fraction, we multiply the numerator by x plus 1, and we multiply the denominator also by x plus 1. So the denominator would be x minus 1 times x plus 1 to the power of 2. The denominators are the same. This is the same as this, and this is the same as this. And again, the order of their factors is not important. Now that the denominators are the same, we write one of the denominators and we start simplifying the numerators. X plus 1 times x minus 1 is x to the 2 minus 1. Again, let me remind you, a plus b times a minus b is a to the 2 minus b to the 2. By using this important identity, x plus 1 times x minus 1 is x to the 2 minus 1. You can use the FOIL method to distribute these two brackets by each other. And finally, the answer that you get by distributing these two brackets by each other would be this. But using the identity makes your operations faster. Then we have negative 2 times x minus 1. Attention, that negative is for all the brackets. So we have negative 2x plus 2. Because 2 times negative 1 is negative 2, but we have this extra negative here, so it makes it positive. And for the last fraction, in numerator, we have 3x plus 3. Plus 3x plus 3. If we simplify the numerator, in numerator we have x to the 2 minus 2x plus 3x minus 2x plus 3x is x minus 1 plus 2 plus 3 is 4. And in denominator we have x plus 1 to the 2 times x minus 1. This is the final answer for this question. I hope by watching this video you have learned about adding or subtracting rational expressions. If this video was helpful for you, please subscribe in my channel and see you in the next videos.